Today we're going to talk very quickly about roots and turns. A root is a point where a line crosses an x-axis. So in this graph of 1/2 x squared minus 3, I have 2 points that can be considered roots. That's where my parabola crosses the x-axis. Notice how the largest exponent in my equation is a 2, so this is a second degree function. And look at how many roots there are. If I moved this graph around without actually turning the graph, could I ever have more than 2 roots? If I pull this parabola down or move it up, will I ever have more than 2 roots? Could I have fewer than 2 roots? Think about that for just a minute. Here I have a third degree function. This third degree function has 3 roots. And again, if I moved this graph up, down, or side to side without turning it, could I ever have more than 3 roots? How about, could I ever have fewer than 3 roots? So here I have an example. This is a really probably horrible sketch of my third degree function. What if I moved it up? If I move my graph up to here, I now only have 2 roots. I have 1 root over here where my graph is touching the axis and another root over to the left. What if I moved it up even further? Now how many roots do I have? Now I would only have 1. Because these lines go on and on forever, it's not possible for me to have no roots, but it is possible for me to have 1, 2, or 3 roots. Turns out that the degree of a function is the maximum number of roots any graph will have. It can have fewer roots than that, but it will never have more. So for instance, if I have f of x equals negative x to the 5th plus 7x to the 3rd minus 9, this is a 5th degree function. I can have a maximum of 5 roots, never more, but I could have anywhere from 0 to 4. A turn is a place on a graph where we change from increasing to decreasing, also known as a relative maximum or a relative minimum. So for instance, in this third degree function, I have 2 points that would be called turns. The first one where I go from increasing to decreasing, the second one where I turn and go from decreasing to increasing. Here I have a second degree function, and it only has 1 turn. There will never be any more than 1 turn in a second degree function. Turns out in any function, the maximum number of turns will be n minus 1, where n is the degree of a function. So an 8th degree function can have up to and including 7 turns. It can have less than that, it just can't have any more than that. Make sure you write down any questions and bring them to class. Have a great day, and I'll see you later.